Hey mathematicians, let's talk about multiplying when there are decimals in your multiplication problem. Okay, so when we're multiplying numbers that have decimals in them, you are going to pretend that those decimals don't exist and just multiply like you normally would. So looking at our first example here, I have 3 times 6 and 5/10. Now, I'm going to pretend that that decimal doesn't exist, and if I pretend it's not there, that number looks like 65. I can multiply 65 times 3. When I stack, I want to put the number with more digits on top. When I multiply this, I get 195. I did the math for you for these examples. You're welcome. But my problem wasn't actually 3 times 65. It was 3 times 6 and 5/10, which is like 6.5. So one strategy is to estimate and say, okay, well, 6.5 is kind of like 7. 3 times 7 is 21. So my answer should be close to 21. If I put my decimal right here, no, that's like 19 or 20 cents. That's not right. If I put my decimal here, that's like $1.95, like close to 2 holes. No, that's not gonna work. If I put it right here, that's 19.5. That's pretty close to 21. And if I put it at the end, it's 195, which is not very close. So that's one strategy to decide, oh, I should put my decimal right here. The other strategy, if you don't like to round and you don't want to estimate, will always work out for you. And what it is you look at your factors, the numbers that you're multiplying, and you add up the number of digits that come after decimal points. So you find the sum, because that's when you get your answer from adding, of the number of decimal places in each factor. So in 3, there's no decimal point. There are no numbers after a decimal point, so that's 0 numbers after a decimal. In 6 and 5/10, there is a decimal point, and there is one digit, one number that comes after the decimal point. So 0 numbers that come after decimal points plus 1 number that comes after a decimal point, that makes 1. So in my final answer, I should have 1 number that comes after the decimal point. So that's another way to check that this is the correct decimal placement. Let's look at these other 2 examples. I already did the math. I pretended the decimals did not exist, and I multiplied 615 times 4. This is what I got. And I multiplied 24 times 332, and this is what I got. So we know how to multiply. Let's just practice putting our decimals in. In 6 and 1500s, there are 1, 2 numbers, digits that come after my decimal point right here. And in 400s, there are 1, 2 digits that come after my decimal point right here. Finding the sum means add them up. 2 plus 2 is 4. So my decimal point should go somewhere where there are 4 digits coming after that. Okay, if I put it right here, oopsie. If I put it right here, there is 1, 2, 3, 4 digits that comes after that. When you're putting your decimal point at the very front of your number, you do have the option to just throw in a 0 at the front to say 0 holes and this many parts of a whole. This would be 246 thousandths or 2,460 10,000ths. So you can choose to put the 0 there. You don't have to, but mathematically it looks better. All right, last example. 2 and 4/10 times 3 and 3200ths. All right, there is 1 digit here after your decimal point. 1, 2 digits here after the decimal point. 1 plus 2 equals 3. So my answer will be, if I put my decimal point, if I put it right here, there are 4 digits after it. If I put it right here, there are 1, 2, 3 digits after. So I should make my answer have a decimal point right here. And again, you can still estimate 2 and 4/10. That's kind of like 2. 3 and 3200ths, that rounds down to 3. 2 times 3 is 6. So you want to put your decimal point somewhere that makes your answer close to 6. 7 and 9/10 is closer than 79 or 796 or 0 and a little bit. So that's another way to double check your answer. And that's how you multiply like normal and add your decimal points in at the end.